Hello everyone, today we'll talk about the solution to the problem find kth smallest pair distance. Feel free to read the statement and think about the problem yourself if you want. Now, in a problem like this, it's classified as a hard problem because we have to answer something about an array that has length that's larger than the original array, that's quadratic with respect to the length of the original array. So we cannot do anything that's too naive, that iterates, for instance, over all the elements of the array of those absolute differences between pairs of elements of the original array. And one approach that sometimes works in cases like this, where we have to find the smallest distance among all the pairs, so something that works is thinking about binary search. Binary search on the answer, trying to look if we change the problem from finding the smallest distance to picking some distance and, for instance, counting the number of pairs that are smaller than it or larger than it, then if it's possible to solve this simpler version, then it's also possible to solve our problem because we can just binary search on the value of the distance that's the smallest that satisfies us. And it's possible to do it here. That's because if we're able to say how many pairs have a distance of at most something, or smaller than something, then we can just find the largest distance with binary search that satisfies our problem. And to find the number of pairs that have a given distance, we can use a sliding window. That's because if we are looking, for instance, at this element, and you want to know the number of pairs, where the first element is from this left side of the array, and this is the right element. Well, there are some possibilities. Of course, here we assume that the original array is sorted, because that makes it easier to think about those things. So let's assume that everything here is okay to create a pair with this one, so their distance is not too big, and here the distance would be too big already, right? It's easy to see that this will be this subarray, because the array is sorted. And now if we want to look at another right element, then the only possible good left elements for it are at most those from this subarray. That's because this element has to be at least as big as this one, and so the absolute difference can only increase if those elements stay the same. But maybe now this element is bad and this element is bad. And then we go to the right, and maybe now this element becomes bad. So our window just slides over. We push the right pointer one by one, looking at the right element, and we maintain the furthest to the left element that still creates a good pair. And at every step, the length of that window is the number of elements that create a good pair with the current right element. The sum overall of those is the number of pairs where the distance is not too big. And so the only thing that remains is to write our binary search. So we sort the numbers, and we need our checker function. And that checker counts the number of good pairs. So we start with the left pointing at the 0th element, we go through all the right elements, and while the distance is too big, we have to move the left pointer to the right and add the length of our subarray to the result. This may be 0, and of course in that case nothing bad happens. And now if the count is smaller than k, which is given in our problem, we return false, otherwise we return true. And now we have to find the largest number such that the number of pairs with distance smaller than it is less than our k. So we start at, let's say, -1, get a jump, and this is the way I write binary searches, with getting smaller and smaller jumps to the right. So while the jump is at least 1, the jump becomes smaller by half at every step. We try to make the jump to the right. If it's still bad, then we can do the jump, otherwise we have to make the jump smaller, smaller and smaller. At some point we'll be making jumps of size 1. At the end we cannot make even a jump of size 1, and in that case our value of start plus 1 is the smallest value for which there are at least k elements, and so this is the answer to our problem.